Your first assignment is to solve the graph coloring problem using TinyCSP solver. The map coloring problem is the one of coloring a set of countries on a map so that no two adjacent countries receive the same color. This problem is a more general version for a graph, and for a graph the goal is to choose one color for each vertex so that no two adjacent nodes receive the same color. Okay? So clearly this problem is slightly more general than the map coloring problem. For the map coloring problem, it was proven using a computer that you can always find a solution using at most 4 colors. But it's not the case for the graph. You can easily imagine that, for instance, if you have a clique of 5 nodes, so every node is connected to each other, you need to have at least 5 colors. So that's not the case that you can always find a solution with at most 4 colors for the general graph coloring problem. So what you need to do for your homework for this assignment, for the programming assignment, is first you need to decide what are the variables of your problem. Then you need to express the constraints in terms of the variables. You need to decide if these constraints are already available inside TinyCSP. If not, you need to implement them. Okay, you also need to decide what are the domains of the variables, and then you need, of course, to express the constraints. Okay, and the constraints is really here again that no two adjacent vertices should be given the same color. So the classes that are provided is the one here is the graph coloring instance that encodes one specific instance that needs to be solved. You are given n, the number of nodes of the graph, and then you have this list of edges, and an edge is a pair of nodes, A, B, for instance, and it is encoded as an array of size 2. So here you've got a list of arrays of size 2, and each array represents one edge. And finally, you receive the maximum number of colors that are allowed in the solution. So you can use the colors between 0 and max color -1. Okay, and the goal here is to implement the solve. This is where you will state your TinyCSP model. So you receive an instance, and what you return is an array of size n that will give for each entry the color that you have chosen for this specific node, the corresponding node at that specific index. So if the problem is unfeasible, you should return null to say that there is no solution to this problem. That's possible, for instance, if the number of colors is not enough for some difficult instances. So your implementation will be implemented inside graph coloring TinyCSP. Don't modify the signature of the method, and don't touch, well, you can of course implement your model inside this class, but do not modify or do not delete this class, because it will be checked for the verification if you want to receive the grades for this project. And the grades will be tested using the graph coloring TinyCSP test. Okay, and you can always test locally the projects on your laptop by executing this unit test. And what we will do is that we will automate the execution of these tests and verify that all the tests pass as expected. For this graph coloring problem, it might be a good idea to use some heuristics. And the way to implement a variable heuristic is, so which variable should we choose next, for instance, for the assignment, is how do we decide what is the next variable x to branch on. One general principle that we use in constraint programming is the first fail principle. And this principle is guided by the following idea. Since all variables must eventually be fixed, if there are no solution under this node, it means that eventually we will discover that there is no solution, then we would prefer to detect it as soon as possible, so that not too much time is spent exploring the subtree under this node. Okay? This is why we say first fail principle. We want to fail as soon as possible if there is no solution there, instead of wasting a lot of time to discover it. And this very generic principle can be instantiated in different manners. A classical way to implement it is to select the variable with the smallest domain first, but that's not the only possibility. You could also select the variable that is involved in most of the constraints. What it means for the graph coloring problem might probably be dependent on the degree of the node of the vertex inside the graph, because the graph of edges is directly linked to the graph of constraints in this case. But I will not extend too much on that topic because we have a specific chapter dedicated to this topic of designing heuristics for constraint programming. So the way to implement this variable heuristic, by default in TinyCSP, the one that you have is that you have the first not fixed variable, which is the one next variable that you will branch on. If you want to replace that one, you could, for instance, replace the first not fixed variable by the smallest not fixed variable. It means that you will iterate over all the variables of your problem, and you will try to discover the one that has the smallest domain size, but you need to choose a variable that is not yet fixed. And so you will iterate over each of them. If you realize that the domain size is less than the smallest domain size that you have seen so far, then you replace this one as the next candidate to branch on. And at the end, you return either the fact that there is no uninstantiated variable, so there are no unfixed variables. And if there is at least one fixed variable, you will return the optional that will capture the one that you have selected.